The next problem in homework 2 is 16a. 16a means repeat problem 15 using nodal analysis. This is the circuit: 2 Henry, 1 ohm, 3 Henry, 1 by 2 farads. It is Vi of t. This is V naught of t. The voltage across inductor is V naught of t. Find the transfer function G of s equals to V naught of s by Vi of s. Vi of s and 2 Henry, 1 ohms, 3 Henry, 1 by 2 farads. Okay. Now we know from t domain, s domain, how they will change. We will see. R becomes R, L becomes SL, C becomes 1 by SC. So here the data given as inductor is 3 Henry, which will becomes 3S, and capacitance is 1 by 2 farads, which will become 1 by S C, 1 by 2, which is 2 by S. So therefore we have to draw the circuit. Again, no need to draw. I'll put here 3S. Okay. Now we have here 2 Henry. For 2 Henry becomes 2S. So 2 Henry becomes 2S, and 1 becomes 1, and this one is 3S, and it will become 2 by S. Okay. Now here V naught of S and Vi of S. This is Vi of S and this is V naught of S. I am changing the circuit from time domain to frequency domain. This is a Vi of S and this is a V naught of S. So same way, the problem we have solved earlier, the same way. So you have to represent here some voltage as V of S. Vx of S, okay, and V naught of S and 2 by S. Now write the circuit like this: 2S minus Vi of S, and this is 1, and this is a 3S, V naught of S, 2 by S. This is Vx of S. Mark the currents. Here I take all currents are leaving. The directions, current directions are like this. So now we know the KCL. Incoming currents, incoming currents equal to outgoing currents. So here at this node there is no incoming currents, only outgoing currents. Therefore outgoing currents we can write as V is equal to IR. So we have Vx of S and V of S. The voltage across this is voltage I is equal to V by Z or R. So this current I1 and I2 and I3. I1 equals to Vx of S minus Vi of S by 2S. Why? Here V is the potential across, voltage drop across that element. So voltage across this element is this minus this. Now I2 is Vx of s by 1, and I3 is Vx of s by, we know if two elements are in series, we can add them to by s. So I3 becomes s by 2 plus 3s square Vx of s. Okay. So now we can apply the KCL. I1 plus I2 plus I3 equals to 0. I1 Vx of s minus Vi of s by 2s plus I2 Vx of s plus I3 s by 2 plus 3s square Vx of s is equal to 0. Now Vx of s by 2s plus Vx of s plus s by 2 plus 3s square Vx of s equals to Vi of s by 2s. Now let's take common 2s into 2 plus 3s square and take Vx of s outside. Now here 2 plus 3x square plus 2s into 2 plus 3x square plus 2x square equals to Vi of s by 2s. I just took this outside, these three. It is having Vx of s on three terms, so I just took outside, and after that I am having 1 by 2s, 1 plus s by 2 plus 3s square. For that I took LCM and I got this one. Therefore now cancel 2s on both sides. So we will be having Vx of s 2 plus 3s square plus 4s plus 6s cube plus 2s square by 2 plus 3s square into Vi of s. 2 plus 3s square plus 4s plus 6s cube plus 2s square. Now Vx of s equals to Vi of s into 2 plus 3s square. I am moving in this direction to s. Now 6s cube plus this 2s square and 3s square. This is 5s square plus 4s plus 2. This is equation number 1. Now we have studied about voltage division. We have Vx of s here, and after that we have 3s, and after that we have 2 by s, and we need voltage across this as output. Now apply voltage division. V0 of s is equal to, this means the voltage across one element equal to total voltage into its impedance by total impedance 3s by 2 by s. Therefore V0 of s equals to Vx of s into 3s square, because s will go up, so 2 plus 3s square. Now so we have Vx of s, so Vx of s equals to 2 plus 3s square by 3s square V0 of s. This is equation number 2. Now put equation 2 in 1. Vx of s 2 plus 3s square by 3s square v naught of s, which is a, in the place of Vx of s we write equation 2, this thing, and after that vi of s into 2 plus 3s square 6s cube plus 5s square four s plus 2 plus 4s plus 2. So now you can cancel this and this. After that we left with v naught of s by 3s square equals to vi of s by 6s cube 5s square plus 4s plus 2. Now move this to this direction and this to this direction. So v naught of s by vi of s equals to 3s square by 6s cube plus 5s square plus 4s plus 2. This is a required transfer function. I will explain one more time the steps. Initially we have a circuit having Vi of t and 2 Henry and 1 ohm and 3 Henry and 1 by 2 farads. For this, first of all, I have converted the circuit into S domain. So for S domain, resistance becomes resistance and L becomes SL, C becomes 1 by SC. So 2 Henry becomes 2S and 3 Henry becomes 3S and 1 by 2 farads becomes 2 by S. So I just wrote this on the circuit, and after that this node they have asked to solve using nodal analysis, so we are using the nodes, that's why it's a nodal analysis. So at this node I represented the voltage as Vx of s and the input is Vi of s because it is in S domain, and output is V naught of s. After that, remember Ohm's law, I is equal to V by R, and KCL is incoming currents equal to outgoing currents. So I represented the currents I1, I2, I3. All are leaving this node. All are going away from this node. So I1 is voltage across this by this impedance. So voltage across this one is Vx of s minus Vi of s by 2s. After that I2 is voltage across this thing is Vx of s by 1, and I3 is voltage across this thing is Vx of s by these two are in series, so 3s plus 2 by s. After that I just simplified this. I3 equal to this s will go up, s by 2 plus 3s square Vx of s. Now add all this together. I1 Vx of s minus V of s by 2s plus Vx of s, s by 2 plus 3x square Vx of s equal to 0. I1 plus I2 plus I3 equal to 0. After that I just divided this Vx of s by 2s. I just divided Vx of s by 2s, and after that we have minus times Vi of s by 2s. I just moved on right hand side, so it becomes Vi of s by 2s. After that Vx of s and s by 2 plus 3s square Vx of s. Now take Vx of s as common here. Vx of s in the these three terms, Vx of s is there, so I just took Vx of s as common. After that we left with 1 by 2s and 1 and s by 2 plus 3s square. So we left with Vx of s, and I took common. I simplified this 3 further. So LCM becomes 2s times 2 plus 3s square, and after that here we need to put what is not there. Here 2s and 2 plus 3s square. 2s is already there, so the remaining is 2 plus 3s square. I have to write here. After that here is 1, there is nothing, so you have to assume 1, so there is 1, so there is nothing here. So you have to write all this 2s plus 2 plus 3s square plus, and it has 2 plus 3s square, so 2 plus 3s square we left with 2s, so we have to put the 2s here, but it is already having s here, so 2s into s and it becomes 2s square. And after that vx of s equals to 2 by we can cancel these two because on both sides 2s is there. After that 2 plus 3s square, so 2 plus 3s square plus 4s plus 6s cube plus 2s square into vi of s. Therefore vx of s, after that move right hand side, so vx of s is equal to vi of s into 2 plus 3s square, it is in the numerator and this one is in denominator. I just added the square terms and arranged in order. This is equation number 1. After that, we have learned about the voltage division. If two impedances are in series, the voltage across this is Vi of s, Vx of s. Total voltage is Vx of s, but we need voltage across this because the voltage across this one is V naught of s. Therefore, apply voltage division. This voltage V naught of s is equal to total voltage Vx of s in times this impedance 3s by total impedance 3s plus 2 by s. So v naught of s equal vx of s into this s goes up, so 3s square 2 plus 3s square, and after that vx of s equal to, just move this 2 plus 3s square by 3s square times v naught of s. This is equation number 2, and just put equation 2 equation 1. Equation 1 on left hand side it is vx of s. In the place of vx of s, you have to put 2 plus 3s square by 3s square v naught of s equals to va of s into, it is already there in equation 1 on right hand side. Right hand side just same as the equation 1, but on left hand side we just substituted this value, this one. After that 2 plus 3s square 2 plus 3s square cancel, so v naught of s by 3s square equal to vi of s by 6x cube plus 5s square plus 4s plus 2. Therefore move this direction and this direction. V naught of s by v of s is equal to 3s square by 6. So which is the required transfer function they have asked. Now to the next question. Question number 22a. 22a. Find the transfer function. So this is this belongs to, these topics are called mechanical to electrical conversion. Mechanical to electrical conversion. These are different questions actually, and other question is 29. 29 also 29. 29 also it is involving mechanical systems, and 34 also mechanical system, and 45 is, yeah, 22a, 29, 34, 35 we will see later. These are all belongs to one group, that is a mechanical to electrical conversion. We will see later, we'll see at the last, or we will see